let's talk about what we do and how this can be applied. So the first step is gathering data and gathering granular data so that we can actually see what's going on. And this can be an eye-opening experience to see what the temperature profile is of every rack in the room and of every cooling unit in the room. And then as well as the layers of power consumption and power consumption throughout the room. And you see in this picture, this is before optimization occurs, that there's some cold areas of the room, there's some warm areas of the room, there's some areas that are okay. This is quite typical. The goal of cooling optimization, of course, is to have everything even, uniform, and consistent. And that's often not the case. So, the first step when we start collecting this data is to realize we do have a problem. And we can go to the next slide and start to capture this data in real time and apply these tools to apply these machine learning and artificial intelligence tools to very complex data sets and start to identify patterns that are very difficult to identify without these tools. One of the really nice features is the ability to identify the airflow patterns underneath the floor. This image is showing you these zones of influence, and each of the cooling units is a particular color, and each of the cabinets is a color that matches the color of the cooling unit that cabinet got its air from. And so the software is able to compare variations in supply temperature from the cooling units with variations in intake temperature at the IT cabinets and find out where the air came from. And you may or may not realize that the air underneath the raised floor doesn't mix very much, actually. Each cooling unit has its own unique plume, and those plumes of air bump up against plumes from other cooling units, and there is a distinct boundary layer. You can see in the right-hand side of this slide that there is an infrared image that I took in a data center, and it shows a 5-degree difference in the supply temperature of air coming out of one corner of a supply tile versus the other corner of a supply tile. And that's because there was a 5-degree difference in the temperature of the air coming from two adjacent cooling units, and that air was bumping into each other and not mixing. So this becomes really useful in identifying things like where is there redundant capacity and how do we make adjustments that actually make a good impact in the room. Because quite often data center operators, with good intentions, are making adjustments to set points and controls, but they're doing it to the wrong cooling unit. You're adjusting the wrong parameter because you don't know what's actually happening in the computer room. So great insights can be realized, and the visuals make it just very, very clear. So continuing on, this is what happens with the application of the optimization. And that's a unique feature of these tools, is that they can pay attention to this data, look at trends, and then provide recommendations. There are a number of people in the industry that have had a lot of experience with optimizing data centers, and some very smart people can write very extensive algorithms to identify trends and patterns and say, okay, well, telling the software, what do we do when we identify and we see a particular condition? And so the operators get engaged in the process, they get the recommendations from the software, and they can make adjustments to get everything even and stable and consistent. And in a lot of cases, warmed up a little bit and closer to that upper range of the ASHRAE recommendations.